Hello everyone, I'm Tatsu, and yeah, I just got up and I'm very sleepy right when I continue to learn Rust. In the last tutorial, uh, I finished the first chapter of the Rust programming language book. So yeah, I finished the second chapter. Okay. Oh, yeah, kind of short. Okay, so let's get started. Uh, in the last tutorial, in the last chapter, I created a Hello Cargo project, and it contains Hello World program. And I executed Rust programs by using uh, Rust C and also using Cargo. Okay, so Cargo runs, yeah. This is the default Rust program. Cargo generated. Println is a macro, not a function, but which is similar to function maybe. I don't know what it is, but yeah, something like functions. And I add hello Japan, yeah, because I'm from Japan. Cargo build, yeah, and cargo run. But actually, hello, I modified China. Oh, sorry. But the only thing I have to do usually is cargo run and skip the build process, and the cargo run command will build and execute the code. Okay, so hello China, hello world, hello China. Okay, that's okay. And cargo.toml is the configuration file or something. And maybe when I add libraries called crates, these will be added into the last part, dependencies maybe. And target is the target directory contains executables and packages for release and so on. So that's why when I cog init, that's added git ignore file to ignore the directory. This executable won't be executed in others' computer. So I can run the executable by directly executing the binary. But usually we use cargo run to run and build and run the code. And so I remember so cargo check command to check the I don't know what it is. Cargo, what is cargo check? Check a local package and all of its dependencies for errors. Yeah, so it's not about compilation, but to check the dependencies and for errors. Yeah. And so when I work on a relatively large project, yeah, cargo run or cargo build will take a lot of time. Yeah, perhaps. So firstly, and kind of periodically, I'll type cargo check to check the uh, correctness of the dependencies and the existence of libraries and so on. So cargo TLDR, cargo, yeah, TLDR is very useful command. Yeah, actually man command is a little difficult to read. Yeah, and relatively long, and so it's very difficult to find useful commands, useful options. But TLDR provides frequently used examples and the descriptions. Yeah, which is very useful. Cargo search, cargo install, cargo init. Oh yeah, I remember cargo init. And cargo add. I don't know. Cargo with race. Yeah, the book referred to it. So back to the Rust program. Main function is almost as the same as C or C++, C main function. The function is executed firstly. There's no return. And cargo lock. It is not intended for manual editing. Cargo automatically generates the file and it describes the name of the package and exact dependencies. Yeah, so this is very useful. And back to the second chapter, and I will continue to learn Rust. And again, I use Z editor. very difficult. Uh, okay, and so programming a guessing game. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You will learn about let, much methods, associated functions, external crates, and more. So crates are libraries, and I remember much is kind of switch statement in other languages, but which is more powerful. And let is kind of is used for using variable declaration. So which is so let is like JavaScript. In the following chapters, we'll explore these ideas in more detail. In this chapter, you just practice the fundamentals. Okay. So in the second chapter, we don't dive into the detailed part. We'll implement a classic beginner programming program, a guessing game. Here's how it works. The program will generate a random integer between 1 and 100. It'll then prompt the player to enter a guess. Okay, after a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. Okay, I understand. Setting up a new project. To set up a new project, go to the projects directory that you created in chapter 1 and make a new project using Kaggle, like so. Kaggle new guessing game. Okay. The first command, Kaggle new, takes the name of the project as the first argument. The second command changes to the new project directory. Okay. Look at the generated Kaggle file. File name Kaggle.tomo. Okay. As you saw in chapter 1, Kaggle new generates a hello world program for you. Check out the SLC main RS file. Exactly the same. That looks the same. Now let's compile this hello world program and run it in the same step using Kaggle run command. Build and run. Okay, hello world. And check. Hello France. Okay. The run command comes in handy when you need to rapidly iterate on a project, as we'll do in this game, quickly testing each iteration before moving on to the next one. Reopen the SLC main RS file. You'll be writing all the code in this file. Okay. Processing guess. The first part of the guessing game program will ask for user input or user input. Process that input. I will check that the input is in the expected form. To start, we allow the player to input the guess, enter the code in listing 21 into SLC/main.rs. Okay, so should remove the lines and I'll use stdio. It looks like C++ using std std. Yeah, using the namespace std. Looks like use or just like so include or so kind of import in Python or required. So using IO package or create or something. The main function print and guess the number. Okay, and print the line and again add the add this line and let mod guess equals string new. It looks like generating a string object, and let is definitely variable declaration. And I remember Rust the variables in Rust cannot be overwritten by default. I remember that. But when I add mod keyword, maybe mutable. Yeah, so by adding it, so I'm able to make the string editable and mutable. I guess so. IO stdin. Yeah, right. After reading the line, I've noticed this is just in C++ using namespace std. Yeah, which is these are the C++ counterparties. This maybe stdin read line. Yeah, it looks like PySerial. Yeah, PySerial. Well, expect. Okay. Stdin that read line, maybe wait the user input and store the string into the variable. And this is kind of error 100 maybe. This is the main function, so generate a string object and input the user input, and you guessed. Okay, this code contains a lot of information, so let's go over it line by line. To obtain user input, and then print the result as the output. We need to bring the IO input out of the library into scope. Oh, this is, oh, not just using namespace, but also uh, IO stream. Uh, maybe use stdio. Also, maybe the the default and accurate way to use the function or method is this. But so maybe can I write the like this? But because I wrote like this, so include the stdio library and also using namespace std, so I don't need to put std before the part, I guess so. Bring the IO input after the library into scope. The IO library comes from the standard library known as std. Like so, in Python, import import IO from std maybe. By default, Rust has a set of items defined in the standard library that it brings into the scope of every program. But okay, this set is called Prelude. Okay, Prelude, and you can see everything in it in the standard library documentation. std future iterator maybe, clone, and so on. IO. Anyway, if a type you wanna use isn't in the prelude, you have to bring that type into scope explicitly with the use statement. Using the stdio library provides you with a number of useful features, including the ability to accept user input. As you saw in chapter 1, the main function is the entry point into the program. Entry point, yeah. The FL syntax declares a new function. The parentheses indicate there are no parameters, so void, yeah. And the curly bracket starts the body of the function, and this is a block, a scope, a local scope here. As we also learned in chapter 1, println is a macro, not a function, that prints a string to the screen, guess the number with new line, ln, and please input your guesses. Okay. This code is printing the prompt, starts what the game is, and requesting input from the user. Storing of values with variables. Okay, next we'll create a variable to store the user input like this. Let mot guess equals string new. Now the program is getting interesting. Yeah, looks interesting. There's a lot going on in this little line. We use the let statement to create the variable. Here's another example. Let apples equals 5. This line creates a new variable named apples and binds it to the value 5. Yeah, like variables like so boxes. In Rust, variables are immutable by default. Yeah, this is very important. Immutable by default. Meaning once we give the variable a value, the value won't change. We'll be discussing this concept in detail in the variables and mutability section in chapter 3. To make a variable mutable, we add mut before the variable name. Let apples equals 5 immutable. Let mut bananas equals 5 mutable. So let I'll test it. Let apples equals 5 and apples is 3. Oh, sorry. Cargo spell. Cargo run. A read error. A value assigned to apples is never read. What? Maybe it is overwritten before being read. Cannot assign twice to immutable variable apples. Yeah. Cannot assign. So after put this. Whoa. Ah, sorry. Sorry. Apples. Various I never read. Maybe it is overwritten before being read. Overwritten before being read. Okay. Remove this. 5. Yeah. Can I override? What? Sorry. Unused. Oh, okay. 5, 3. Okay. But when I remove it, oh, this spews, generates the error. And back to the main program. The backslash, double backslash, oh, no backslash. double slash. Syntax starts a comment that continues until the end of the line. Rust ignores everything in comments. We'll discuss comments in more detail in chapter 3. Okay. Returning to the guessing game program, you now know that let mod guess will introduce a mutable variable named guess. The equal sign tells Rust we want to bind something to the variable now. On the right of the equal sign is the value that guess is bound to, which is the result of calling string new, a function that returns a new instance of a string. New instance, string instance, okay? A string is a string type provided by the standard library that is growable, UTF-8 encoded bit of text, okay? The double colon syntax in the new line, this indicates that new is an associated function of the string type. Yeah, which is very similar to double colon in C++. So I know that. An associated function is a function that's implemented on a type, in this case, string type. Implemented on a type string. Okay, I get it. This new function creates a new empty string. You'd find a new function on many types because it's a common name for a function that makes a new variable, variable of some kind. Um, what? Oh, okay, so except for string, other types, something new, there, yeah, some other types, yeah, containing new function, maybe. Receiving user input. Recall that we included the input-output functionality from the standard library which uses stdio, the first line of the program. Now we'll call the stdin function, yeah, from the IO module, which will allow us to handle user input. If we hadn't imported the IO module which uses stdio at the beginning of the program, we could still use the function by writing this function called as stdio stdin exactly like this. The stdin function returns an instance of stdio stdin, okay, which is a type that represents a handle to the standard input for your terminal. std, okay. Next the line, the least line, not guess. Yeah. This ampersand is like, yeah, so reference, yeah, that it looks like a reference in C++. Yeah, right. We're also passing and not guess as the argument to read line to tell it what string to store the user input in. The full Java read line is to take whatever the user types into standard input and appear that into string without overriding its content. So we therefore pass that string as an argument The string argument needs to be mutable, so the method can change the string's content and explain it. The and indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. Yeah, just a reference. Okay, references are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot of those details to finish this program. For now, all you need to know is that like variables, references are immutable by default. Hence, you need to write and not guess rather than and guess to make it mutable. So make it mutable. Okay. Handling potential failure with result. Result looks a type, a kind of type. Yeah. We are still working on this line of code. We are now discussing a third line of text. But know that it's still part of a single logical line of code. The next part is this method. We could have written this code as std read write blah blah blah. So one line is well. Yeah. However, one long line is difficult to read. Yeah. So it's best to divide it 3 lines, multiple lines. It's often wise to introduce a new line and other white space to help break up long lines when you call a method with the method name syntax. Now let's discuss what this line does. Here, I feel like I often so this kind of syntax or the way of writing code in JavaScript and TypeScript, dot method, and so on. As mentioned earlier, real-line puts whatever the user enters into the string we pass to it, but it also returns a result value. Result is an enumeration, enum, often called an enum, which is a type that can be in one or multiple possible states. We call each possible state a variant. States, it stores states. Oh yeah, enum. Okay, error. Result is a type that represents either success or failure. Contains success value, contains error value. Okay. And chapter 6 will cover enums in more detail. The purpose of the result type is to encode error handling information. A results variants are OK and error. The OK variant indicates the operation was successful and it contains the successfully generated value. The error variant means the operation failed and it contains information about how or why the operation failed. Values of the result type, like values of any type, have methods defined of them. An instance of result has an expect method that you can call if this instance of result is an error value. Expect will cause the program to crash and display the message that you passed as an argument to expect. If the readline method returns an error, it'll likely be the result of an error coming from the underlying operating system. If this instance of result is an OK value, expect will take the return value that OK is holding and return just that value to you so you can use it. In this case, that value is the number of bytes in the user's input. If you don't curry expect, the program will compile, but you get a warning. Rust warns that you haven't used the result value returned from a line, indicating that the program hasn't handled a possible error. The right way to suppress the warning is to actually write error handling code, like the try, expect in other languages. But in our case, we just want to crash this program when a program occurs, so we can use expect. You'll learn about recovering from errors in chapter 6. Printing files with printer and placeholders. Aside from the closing curly bracket, there's only one more line to discuss in the code so far. This line prints the string that now contains the user's input. The curly braces set of curly brackets is placeholder. Yeah, placeholder. Think of curly braces as little crab pincers that hold a value in place. When printing the value of a variable, the variable name can go inside the curly brackets when printing the result. Evaluating an expression, press empty curly brackets in the format string, then follow the format string with a comma separated list of expressions to print in each empty curly bracket for placeholder in the same order. Yeah. Printing a variable and the result of an expression in one code to printer and would look like this. Let x equals 5, let y equals 10, printer and x equals this. And it'll be replaced by this. Also y x equals x, what? Nice little graphics. Okay. So I can write that inside the curly braces, or just put an empty braces and write the content after, and it'll replace it. This code will print x equals 5 and y plus 2 equals 12, because 10 plus 2 equals 12. Testing the first part. Let's test the first part of the guessing game run using Kaggle Run. Please input your guess. 30. You get 30. Okay. At this point, the first part of the game is done. We are getting input from the keyboard and then printing it. Generating a secret number. Next, we need to generate a secret number that user will try to guess. The secret number should be different every time, so the game is fun to play more than once. We use a random number between 1 and 100, so the game isn't too difficult. Rust doesn't yet include a random number functionality in its standard library, okay? However, the Rust team does provide a run crate with said functionality. Using a crate to get more functionality. Remember that a crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The run crate is a library crate, which contains code that is intended to be used in other programs and can be executed on its own. Kaggle's coordination of external crates is where Kaggle really shines. Before we can write code that uses run, we need to modify the kaggle file to include the run create as a dependency. Open that file. Now add the following line to the bottom. It is the dependency section header that Kaggle created for you. Be sure to specify run exactly as we have here with this version number, or the code examples in the tutorial may not work. Okay, run equals 0, 8, 5. In the Kaggle Tomo file, everything that follows the header is part of that section that continues until another section starts. In dependencies part, you tell Kaggle which external crates your project depends on and which versions of those crates you require. In this case, we specified run crate with the specific version, a semantic version specifier 0.8.5. Kaggle understands semantic versioning, sometimes called semver, which is a standard for writing version numbers. The specifier is actually shortened for, I don't know how to pronounce it, but blah blah blah, which means any version that is at least 0.8.5 but below 0.9.0. Okay. Kaggle considers these versions to have public APIs compatible with version 0.8.5, and this specification ensures you get the latest patch release that is to compare with the code in the chapter. Any version 0.9.0 or greater is not guaranteed to have the same API as what the following examples use. Okay. Now, without changing any of the code, let's build the project as shown in listing 2. Okay. Oh, run is added. Yeah. Okay. Run the version 0.8.5. Okay. You may see different version numbers, but they will all be compatible with the code thanks to similar different lines, depending on the operating system, and the lines may be in a different order. When we include an external dependency, Kaggle fetches the latest versions of everything that dependency needs from the registry, which is a copy of the data from crates.io. Crates.io is where people in the Rust ecosystem post their open source Rust projects for others to use. After updating the registry, Kaggle checks the dependencies section and downloads any crates listed that aren't already downloaded. In this case, although we only listed run as a dependency, Kaggle also grabbed other crates that run depends on work. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. If you immediately run Kaggle build again without making any changes, you won't get any output aside from the finish line. Kaggle knows it has already downloaded and compiled the dependencies, and you haven't changed anything about them in your Kaggle.toml file. Kaggle also knows that you haven't changed anything about your code, so it doesn't recompile it either. With nothing to do, it simply exists. If you open the SOC main.rs file, make a trivial change and then save it and build again, you only see 2 lines of output. trivial change. Okay, guess the number add an additional exclamation mark. Compiling guessing game. Yeah. These lines show that Kaggle only updates the build with your tiny change to the associated /main.rs file. Your dependencies haven't changed, so Kaggle knows it can reuse what it has already downloaded and compiled for those, ensuring reproducible builds with the Kaggle log file. Kaggle has a mechanism that ensures you can rebuild the same artifact every time you or anyone else builds your code. Kaggle will use only the versions of the dependencies you specified until you indicate otherwise. For example, say that next week version 0.8.6 of the run crate comes out, and that version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates the Kaggle log file the first time you run Kaggle build, so we now have this in the guessing game directory. When you build a project for the first time, Kaggle figures out all the versions of the dependencies that fit the criteria and then writes them to the Kaggle log file when you build your project in the future. Kaggle will see that the Kaggle log file exists and will use the versions specified there rather than doing all the work of figuring out versions again. This lets you have a reproducible build automatically. In other words, your project will remain at 0.8.5 until you explicitly upgrade thanks to the Kaggle log file, because the Kaggle log file is important for reproducible builds. It's often checked into source control with the rest of the code in your project. Okay. So look the version of crates. Kaggle log. Do so. Updating the crate to get a new version. When you do want to upgrade crate, update a crate, Kaggle provides the command update, which will ignore the Kaggle log file and figure out all the latest versions that feature specifications in Kaggle Tomo. Kaggle will then write those versions to the Kaggle log file. In this case, Kaggle will only look for versions greater than 0.8.5 and less than 0.9.0. If the run crate has released the two new versions, you'll see the following if you run Kaggle update. Okay. Kaggle ignores the there's no unchanged dependence. Variables. A variable 0.9.2 how to update. To see how you depend on a package on Kaggle tree import. What? 0.9.2 0 package is the latest plus 1.91.1 compatible versions. There's no compatibility. Okay, I'll explicitly update the version. What? Okay, okay. In 0.9.2. Okay. The next time you run Cargo will update the registry of crates available and evaluate your run requirements according to the new version you have specified. There's a lot more to say about Cargo and its ecosystem, which we'll discuss in chapter 14, but for now, that's all you need to know. Cargo makes it very easy to reuse libraries, so Rustaceans are able to write smaller projects that are assembled from a number of packages, generating a random number. Let's start using run to generate a number to guess. The next step is to update associated main arrays as shown in listing 2 3. Update it. Use stdio, use run rng, fn main, get guess the number, red secret number equal run thread rng the gen range 1 100 1 to 100. Print the secret number is secret number. Okay. Print please input your guess. Let not guess in string new io std in read line and sorry, let guess and fail to read line. Okay, get the end. You guess. Okay, and cargo build. What? Use of deprecated function round thread rng named to rng. Okay. Use a deprecated random gen range named random range. Cargo build. Okay. Cargo run. You guessed. Okay. First, we add the line use round RNG. The RNG trait defines method that random number generators implement. And this trait must be in scope for us to use those methods. Chapter 10 will cover traits in detail. Traits? Okay, trait, yeah. Next, we are adding 2 lines in the middle. In the first line, we code run thread RNG function. But in my environment, RNG is more newer function that gives us a particular random number. Yeah, so access a fast pre-initialized generator and hence use function that gives us generator. We are gonna use one that is local to the current thread to its execution and is seeded by the operating system. Let me call the gen range, but in my case, random range method on the random number generator. This method is defined by the RNG trait that we brought into scope is used around the RNG statement. The gen range method takes a range expression as an argument and generates a random number in the range. The current range expression we are using here takes the form start dot dot equals and then is inclusive on the lower and the upper bounds, so we need to specify to request a number between 1 and 100. It contains 100 maybe because it has equals sign. You won't just know which try to use. Yeah. Cargo doc open. Command will the documentation provided like all your dependency will carry and operate in your browser. Oh. The second new line prints the secret number. This is useful while we are developing the program to be able to test it, but we'll treat it from the final version. It's not much of a gain if the program prints the answer as soon as it starts. Try running the program a few times. Yeah, I tried. I already tried it. Yeah, you should get different random numbers. 76, 89, 99. Okay. Comparing the guess to the secret number. Now that we have user input and the random number, we can compare them. That step is shown in listing 2.4. Note that this code won't compile just yet, as we will explain. Sorry. I just want to take a rest. Sorry, I just came back. Let's proceed with loading Rust and create KCK. And snip the code snippet. Okay, and so at line you guess. Okay, I already have that now. Match guess.cmp compare and secret number ordering less. I have to include it. Use std cmp ordering. Yeah. Less print to add 2 small and comma ordering greater to be what what ordering equal println you win. Okay, and let's review the secret number. Found the difference. Mismatch types. What? Secret number. What? Yeah. Build. Mismatch types. Expected reference. String. But this is an integer. What? Anyway, first we add another use statement bringing a type code as std_cmp ordering into scope from the standard library. The ordering type is another enum and has the variants less, greater, and equal. These are the three outcomes that are possible when you compare to values. Then we add 5 new lines at the bottom that use the ordering type. The CMP method compares two values and can be called on or anything that can be compared. Yeah, it takes a reference to whatever you want to compare with. Here it's comparing guess to secret number, then it returns a variant of the ordering we brought into scope with the use statement. It is a match expression to decide what to do next based on which variant of ordering was returned from the code to CMP with the values in guessing the secret number. A match expression is made up of arms. Arm. Yeah. An arm consists of a pattern to match against and the code that should be run if the value given to match fits that arm's pattern. Rust takes a value given to match and looks through each arm's pattern in turn. Patterns and the match construct are powerful Rust features. They let you express a variety of situations your code might encounter, and they make sure you handle them all. These features will be covered in detail in Chapter 6 and Chapter 19 respectively. Let's walk through an example with the match expression we use here. Say that the user has guessed 50 and randomly generates secret number. This time is 38. When the code compares 50 to 38, the CMP method will return ordering greater because 50 is greater than 38. The match expression gets the ordering greater value and start checking each arm's pattern. It looks at the first arm's pattern, ordering rest, and sees that the value greater than the blah blah blah. So it ignores the code in that arm and moves to the next arm. 1, 2, 3. Yeah. The associated code in that arm will execute and print too big to the screen. The match expression too big because 50 is greater than 38 to the screen, and the match expression ends after the first successful match, so it won't look at the last arm in this scenario. However, the code won't compare it. Let's try it. And the 3 arms cover every case. Yeah, as long as the user input is provided as an integer. Less, greater, equal. Yeah. The core of the error states that there are mismatch types. Yeah, I have it. Rust has a strong static type system. However, it also has type reference, if type inference. When we wrote let not guess string new, Rust was able to infer that guess should be a string and didn't make us write the type. The secret number, on the other hand, is a number type. A few of Rust's number types can have a value between 1 and 100. I32-bit number, U32 an unsigned 32-bit number, I64 blah blah blah. So that it goes Rust for a different numerical type. The reason for the error is that Rust cannot compare a string and a number type. Guess is a string type. Guess has string type. And secret number is an integer. So I couldn't compare these two values, yeah, which have different types. Ultimately, we want to convert the string the program with an input into a number type so we can compare it numerically to the secret number. We do so by adding this line to the main function body. Okay, std in let guess what is this redeclaration? I don't know. Guess the trim parse expect please type a number, and this part is error handling, and parse is passes the string slice into another type. Trim is white space. Remove white space. Okay. The line is the error marker disappeared. Past the build. We create a variable named guess, but wait, doesn't the program already have a variable named guess? It does, but helpfully Rust allows us to shadow the previous variable guess with a new one. Shadowing, yeah. Lets us reuse the guess variable name rather than forcing us to create two unique variables, such as guess steer or guess, for example. We'll cover this in more detail in chapter 3, but for now, know that this feature is often used when you want to convert a value from one type to another type. So shadowing, okay, this is called shadowing. Okay, shadowing. User input, shadowing, and convert the string type to unsigned 32-bit integer type. Okay, and know that this feature is often used when you want to convert a value from one type to another. Okay, we bind this new variable to the expression guess or trim that parse. The guess in the expression refers to the original guess variable that contains the input as a string. The trim method on a string instance will eliminate any white space at the beginning and end. Yeah. Which we must do before we can convert the string to a U32, which can only contain numerical data. The user must express enter to satisfy uline to input the guess, which adds a new line character to the string. For example, if the user types 5 and presses enter, guess looks like this. 5 backslash n. The backslash n represents new line. On Windows, pressing enter results in carriage return a new line. Blah blah blah. The tree method eliminates backslash n or backslash r backslash n resulting in just 5. Yeah, remove the last so special character, and so take the only pure integer number. Yeah. The parse method on strings converts the string to another type. Yeah, here we use it to convert from a string to a number. We need to tell Rust the exact number type we want by using let guess. You started to. Yeah, the current after guess tells Rust will annotate the variables type. Okay, this is annotation. Rust has a few built-in number types. The you started to seeing here is an unsigned 32-bit integer. It's a good default choice for a small positive number. You'll learn about the other number types in chapter 3. Additionally, the U30 annotation in this example program and the comparison with secret number means Rust will infer that secret number should be a U32 as well. So now the comparison will be between two values of the same type. The parse method will only work on characters that can logically be converted into numbers and so can easily cause errors. If, for example, the string contains a good %, there will be no way to convert that to a number because it might fail. The parse method returns a result of result type, much as the read-write method does. Discuss area and handling potential variance result. We'll treat this result the same way by using the expect method again. If parse returns an error, result variant because it couldn't create a number from the string, and the expect call will crash the game and print the message we gave it. If parse can successfully convert the string to a number, it will return the OK variant result, and expect will return the number that we want from the OK value. Let's run the program now. Kaggle run 60. Too small, too big. You win. Okay. And nice, even though spaces were added before the guess, the program will still figure out. Add 3 white space and 3. Okay, too small. Okay, that's correct. Then the program will still figure out that the user guessed 76. Run the program a few times to verify the different behavior with different kinds of input. Guess the number correctly. Guess the number that is too high, and guess a number that is too low. We have most of the game working now, but the user can make only one guess. Let's change that by adding a loop. Yeah. While loop or for loop or, but I know Rust has loop statement. Loop statement or loop expression. I don't know. The loop keyword allowing multiple guesses with looping. The loop keyword creates an infinite loop. We'll add a loop to give users more chances at guessing the number. Presume to guess. As you can see, we've removed everything from the guess input prompt onward into a loop. Be sure to indent the lines inside the loop another 4 spaces each and run the program again. The program will now ask for another guess forever, which actually introduces a new program. It doesn't seem like the user can quit. And please input addresses. loop much. Yes. Okay. Cargo. No. Too small. Too big. You win. But I couldn't finish the game. The user could always interpret the program by using the keyboard shortcut Control plus C. Yes. But there's another way to escape this insatiable monster. As mentioned in the past discussion in comparing the guess to the secret number, if the user enters the known number answer, like the known number answer, the program will crash. We can take advantage of that to allow the user to quit, as shown here. Quit. Typing quit will quit the game, but as you notice, you will entering any other non-number input. This is suboptimal, suboptimal, to say the least. We want the game to also stop when the correct number is guessed. Quitting after correct guess. Equal. Println you win and break the infinite loop. Okay, adding the break line after you win makes the program exit the loop when the user guesses the secret number correctly. Exiting the loop also means exiting the program, because the loop is the last part of me. Yeah, last part of me. Handling invalid input. To further refine the game's behavior, rather than crashing the program when the user inputs a known number, let's make the game ignore a known number so the user can continue guessing. We can do that by altering the line where guess is converted from a string to a U32, as shown in listing 2.5. STD guess much parse okay num error. So maybe it looks like the catching every error, every case of error. Okay, what? Ignore all fields. Okay, we switch from an expect code to a match expression to move from crossing an error to handling the error. Remember that the parse returns a result type, and result is an item that has the variants OK and error. We're using the match expression here, as we did with the ordering result of the CMP method. If parse is able to successfully turn the string into a number, it will return an OK value that contains the resultant number. That OK value will match the first term's pattern, and the match expression will just return the noun value that parse produced and put inside the OK value. The number will end up right where we want it in the new guess variable we are creating. If parse is not able to turn the string into a number, it will return error, yeah, and continue and pass the loop. pass the case, skip the case, and that contains more information about the error. The error value does match okay now pattern in the first match arm, but it does match the error pattern in the second arm. The underscore is a catch-all value. In this example, we are saying we want to match all error values no matter what information they have inside them. So the program will execute the second arm's code, continue, which tells the program to go to the next iteration of the rule and ask for another guess. So effectively, the program ignores all errors that parse might encounter. Now everything in the program should work as expected. Let's try it. Let's try 1 too small and add the white spaces. Okay, and 90 too big. Okay, and when I type the correct answer, print the code printed you win this line and execute no, exit the code because it contains the break line, and so break the loop and exit the main function. And also with one tiny final trick, we will finish the guess again. Recall that the program is still printing the secret number that worked well for testing, but it ruins the game. yeah. Let's delete the printer that adds with the secret number. This no. Secret number is no. Spoiler. Cargo run. Sorry, too small. 60, too small. 90, too big. 80. Oh, you win. Okay. At this point, you've successfully beat the guessing game. Congratulations. Okay. I could meet the ideal behavior expected. Okay. Summary. This project was a hands-on way to introduce you to many new Rust concepts, let, match functions, the use of external crates, and more. In the next few chapters, you'll learn about these concepts in more detail. Chapter 3 covers concepts that most programming languages have, such as variables, data types, and functions, and shows how to use them in Rust. Chapter 4 explores ownership, a feature that makes Rust different from other languages. Yeah, ownership and lifetime and so on. Chapter 5 discusses trackdown method syntax, and Chapter 6 explains how enums work. And I just finished the second chapter, but that's too long. Yeah. Oh, 88 minutes. It takes a lot of time. Yeah, only this part. Okay, so I'm still not sure about, yeah, kind of shadowing and what the loop is. And this part and so on, and match expression, but I'll figure out these concepts later, maybe. I hope so. So today I'll finish the video, so bye. So in the next tutorial, yeah, I'll dive into the common programming concepts, chapter 3. In the third chapter, yeah, I learned data types, functions, and very common concepts appear in programming. Okay, So I'm very excited to learn this. So bye.